Here is an application problem where rate of change is being considered as velocity, right? Velocity is rate of change of displacement. Now the question here is, a ball is thrown into the air with a velocity of 20 meters per second. Its height in meters after t seconds is given by y equals to 20t minus 5t square. Find the velocity of the ball after 1 second, 2 seconds and 3 seconds. So we have to find instantaneous rate of change of height with time, right? Change in height is like change in position, and therefore it's being referred to as velocity. So velocity is change in position. It could be distance or height or depth, correct? All those positions. So we need to find velocity of the ball after 1 second, 2 seconds, 3 seconds. So one approach is that we can find three different answers. So one approach is that we can use difference quotient formula or method and apply it 3 times to get the velocity for each point, right? When t equals to 1 second, t equals to 2 seconds, and t equals to 3 seconds. But a preferred manner will be to find general expression in terms of a point A, right? When t equals to A, then what is going to be the velocity? And at the end, we'll substitute different values of A, that is 1, 2, and 3, and get our answer, right? So I'll show you how to do this. So this is a displacement, change in position, in this case height. Now rate of change of height will give us velocity, right? So we'll say m is equals to limit when h approaches 0, and we are considering a point at general point, which is at t, right? So we'll say f of t plus h minus f of t over h. So t is any general point t, right? I could have written a and then substituted for a, but I'm just keeping it simple. So I'm just writing t at present, okay? So any general point t on this function. So we get limit h approaches 0. So t plus h will be replacing this t with t plus h. So which gives us 20 times t plus h minus 5 t plus h whole square, right? That's the first term, right? Let me put it in the bracket. Minus f of t, that is the same term. 20t minus 5t square over h. Now let's expand and simplify. We get 20t plus 20h minus, let's expand this, t square, right? So 5 times t square plus 2 times th plus h square. So this is the first part. Minus, here we have 20t minus 5t square divided by h, right? Now, as you can see, 20t and 20t is 0, and 5t square and 5 times t square will be 0. So rest terms are remaining for us. Let's write them down. Limit h approaches 0, and here you see h is common factor, right? So we'll factor out h and then write it down. H, and h, right? So we'll factor this h out and then write our expression. So we have 20h. So we can take, and we have, so we'll take h common, right? So when I take h common in the numerator, I get 20 and minus 5 times 2t, which is minus 10t, right? And then minus 5 times h square, and we have already taken h common, so I'll write minus 5h. So that's what we get, divided by h. Now this h and h cancel out, and so we are left with limit. Now since this cancel out, then we can substitute h equals to 0 and calculate the limit, right? So if I put h equals to 0 here, I get 20 minus 10t. It is 20 minus 10t. So that becomes an expression which represents slope of this function at any point t. That means velocity at any point t, correct? So that's what it means. Now from here, I can find velocity at different times. 1 second, I'll put t as 1. 2 seconds, I'll put t as 2. 3 seconds, I'll put t as 3. So I get velocity when t equals to 1 will be, I'll put t as 1. So it is 20 minus 10, that is 10. And the units are meters per second. So that is my answer for velocity at t equals to 1. Similarly, velocity at t equals to 2 will be 20 minus 10 times 2, which is 20, and so I get 0 meters per second. And velocity at t equals to 3 will be 20 minus 3 times 10, 30. So we get minus 10 meters per second. So that is our answer. Does it make sense? I think it does. It shows that there is a turning point at t equals to 2. So it's kind of like this. The ball is thrown upwards. That means the ball goes up like this, and then it returns. And what's happening here is this thing happens at t equals to 2. And from the symmetry, we can see that the velocity going up is same as velocity coming down, except for a different sign, correct? And at t equals to 2, we have the maximum height of the ball, and that's the turning point. I hope that this type of an application gives you a lot of insight into the application. I hope you appreciate it. Thank you and all the best.